So this is what we'd like to be having. This class temperature is very important when we give you the name of a class, of a method, of a variable. You have to respect and use that exact same name. So if I tell you to write temperature, temp doesn't do. It's not enough. Or T, not enough neither. If I would tell you temperature, it has to be temperature. You have to get this habit of work as part of a team. If we tell you to do this, this is what we expect you to do. So do what you are expected to be doing. So let's get in here and close all those. I just don't want to see this on startups of any. So let's create a new project. Let's name it week 11 13 exercise temperature. So this is my name of my main class. Always try to separate, just for the convenience of having the main method, this one over here, separated from your own classes so you don't get things mixed up. It is a common practice, a good practice to separate those. So I'd like to have this temperature. This is my class, finish. Maybe I can move these out of the specific package just to make it easier for me to share it later on. Move classes, refactor. So let's delete this one. So in this one I'm going to test my class, and in this one I'm going to define my temperature class. So let's look at the requirements. Okay, this one, yeah. So we would like to have only 2 instance variables. So we don't want you to create more than 2 instance variables. So we have like the temperature value and the character for the scale. So I'm going to go for these 2 values, make them private. The first one, let's name it value, for example, and private char scale. This is what we want, just 2 values. Let's continue. So we know that the scale is going to be either C or F. So if something else is provided, we need to deal with that. So first of all, let's continue and see what about those constructors. So the class should have 4 constructor methods. Yes?
That's why you define C by char.
Because we said 1 character, and the data type that takes only 1 character is char. You can use a string, but this is a waste of resources because we need only 1 character. And also, whenever you see something with a single quote, this is usually referring to the use of a char, because this is 1 character is permissible, and 1 character is enough for us to distinguish between if the temperature is in Fahrenheit or if it is in Celsius, just by having like C and F. So that's why they chose to use that. Now we're going to start the work on the constructors. We said the constructor is the one that is a method that has the same name than the class. So I'm going to write public temperature, and then I am going to see what are the different constructors that I need to create, to define. So I'm having like 1 for each instance variable. That means I am going to have a constructor that takes only a double, and then another one that takes only a char. Assume 0 degrees if no values is specified, and Celsius if no scale is specified. So that means if I'm going to like this double value, so the value, this dot value is going to have value, but what about the scale? Scale is going to be, I'm going to specify Celsius if no scale is specified. In this case, there's no scale specified, so I'm going to assume that this is Celsius. So if I'm using this constructor to create my instance, my object from the class temperature, and I'm giving only like a value 5, by default I am going to assume that this 5 is in Celsius. Okay, so this is what this constructor is allowing me to do. Now I'm going to be doing the same thing again with the constructor that takes only a char as a scale. If you give me only the scale, well, but what about the value? What am I putting inside of that value? It says assume 0 degrees if no value is specified, because I just specified the scale without a value, so I am assuming that the value is 0. And this is what this first part meant. So this is over. Now this is done. I'd like to be doing this one right now, one with 2 parameters for 2 instance variables, which is I am going to be having something, let's say like this, maybe this one, copy and paste, and I need the 2 variables. So these are the 2 arguments, the value and the scale, and I have the value and I have the scale, so I am going to be putting those arguments into the parameters, into those values, instance variables. So now this is done. A no argument constructor sets to 0 degrees Celsius, so I need to be doing this one. Well, this is something that I need to be just, let's copy this for example and use no arguments and just put 0, and we said we're going to assume that this is in Celsius, 0 Celsius. This is what they said, so we're going to respect that, and now that's it, and we finished this requirement. Any questions up to here? Is it easy, clear?
Suppose replace C by 0.
C, but C is a char that is going to be used only to distinguish between the 2 scales. Is it a degree in Celsius or a degree in Fahrenheit? So if you put 0 here, I will not be able to understand. Is this value a Celsius or a Fahrenheit? Because it's a 0 and I don't know what 0 means. So in this scale I'm going to put only 2 values, C or F, to distinguish between the Celsius and the Fahrenheit. And in here, the value, this is going to be the degree, the value of that temperature. So that's why I'm separating those. Now I need to do this, the following. Okay, let's have a look at these 2 accessors that return the temperature. But this, I'm going to look for the first one, get temp Celsius. Okay, public. Okay, first of all, get temp Celsius should return something. What is the data type of that return value? Am I going to return a double or a char? Double? Well, yes, because I need to return the degree in Celsius, so I know that this is going to be in Celsius. I just need to return the value. That's all I need, and the value is for us in double, so that's why I am going to return a double. And then this is called get temp Celsius. I'm going to respect how this is spelled, Celsius with S, sorry. So I'm respecting the spelling. And do I need to give any arguments? No, because the getting, I just need to, I have all the information, I just need to return something. Now what am I returning? Can I do this? Return value? Well, there's only one value, but that value can be either in Celsius or in Fahrenheit. But how can I distinguish between those two? Well, I need to check first if the scale is equal to C, then I know that I just need to return the value because the value is already prepared to have something like this. But what if the scale is equal to F? Then I will need to have the formula. Okay, what I'm going to be doing, because I know that if it's C, it is not F, I can just use this else, because I am going to control how my values are going to be stored. It's either C or F, right? But did I control something here? I'm just thinking that if I put a value, it is going to be C, okay? If I put a scale, I'm not testing. If I put scale of Z, it is going to be accepted and put in the scale. So I need to improve my things over here. Okay, so we were saying that if we accept any char and we put it in the scale, we might later on have some problems. So what we should do, actually, we should always test if scale is equal to C or scale is equal to F. In that case, I will accept the value and save it in the instance variable. If this is not, if this is a problem, I'm going to put by default like scale, put it C. Let's just make sure that this is C, because we said that this is the default one. And notice that I have a warning that warns me, well, look, what you're doing, if you're doing something like this, you're just changing this value, not the value of this instance variable. So what I need to be doing, just to make sure to distinguish what I mean this one over here. So I'm always checking. If you give me a scale, I need to check either to make sure that it's either an F or a C. And I'm not allowing anything. If you enter anything else like Z, A, B, whatever, it is going to put the C by default. Yes.
Accept a small c.
No, a lowercase c is going to be rejected, and if I want this lowercase c to be accepted, I can just need to make it an OR, but this is going to complicate my coding. Or maybe there's some other ways to do that. Maybe I can then change it to string, so I can use this to lower or something like ignore case or equals ignore case, something like that. But for the sake of this exercise, let's keep it simple. We only accept C and F, even if it undermines the usability of the class, but it's not a big deal for this exercise. So whenever I'm getting a scale, I am always going to perform this type of checking. And if the scale is okay, I'm going to save it. If it is not okay, I'm going to do that. So all this is going to be replaced by something like this. I can improve that by putting all this in a method every time I just call that method. But for now, let's keep it simple again. So you understand what I did? I just added this checking that whenever you give me a scale, I'm making sure that the scale is either C or F. If you're giving me something else, I'm going to put by default like it's C as a Celsius. So get the temperature. I checked first of all if the temperature is if the scale is C and it's already Celsius. So just let's return only the value. If it is not in Celsius, well, I need to return the result of that operation, which is I need to return a Celsius. So I need to multiply 5 by Help me here. What should I type? Value, because in this case I named it value, minus 32 divided by 9. One thing I'd like to make sure that this is a double minus an int, this is still a double, and this is going to be double divided by int, so it's double. If for whatever reason I decided that this is not int, this is not double but int, then this is going to give me a problem, because this is int minus int divided by int. It is going to give me an int, so it will not be accurate. So that's why we're on the safe side when we use this value to be on double. So this is the get temperature in Celsius. Now it's quite similar almost to get the temperature in Fahrenheit. So we would like to now get the temperature in Fahrenheit. So let's see that this is done. Now we're working on this one. Get temp Fahrenheit. With the temperature in Fahrenheit, if the scale is already in Fahrenheit, just return the value. If it is not, I just need to perform this operation, which is 9 multiplied by, well, I can just have the value divided by 5, and all of them plus 32. Is everybody okay? Any questions? No? I like it when nobody, no, I don't. Okay, so you don't have a question, which means I just would like to make sure that you understood this, okay, even if you don't have any questions. In the get temperature in Celsius, okay, because I'm asking to return the temperature in Celsius, I'm checking if the scale is already in Celsius. Then I'm only returning the value because I know that the temperature was already stored in Celsius. Now, if it is not the case, if this is not, the scale is not Celsius, that means my temperature is stored as a Fahrenheit. Since my temperature is stored as a Fahrenheit, this is a Fahrenheit value that I need to convert to a Celsius value by doing this formula, executing this formula. So when I'm returning the temperature in Celsius, I know that this is the value in Celsius, because I converted the Fahrenheit to Celsius. But in the first case, if it was already in Celsius, I don't have to do any operation. Just give me the value because it's already in Celsius. I don't need to do any other thing. And I'm doing the same thing here in Fahrenheit. If I'm looking at the scale and I find that it's Fahrenheit and you want me to return a Fahrenheit, well, I'm just going to return the value. But if it wasn't Fahrenheit, then I'm going to go into the else, and then I am going to return the converted degree to Fahrenheit, and this is going to be the result of this call. Yes, what was your question? With the letter F, with the scale? 9 multiplied by value. Okay, good question. Should I have this? Well, if I don't do it, it is going to be done by the compiler itself. Why? Because you remember, when we're talking about this precedence and associativity, when some operators have the same level, like this multiplication and division, which one are we going to be starting with? From the left to the right. So this is what is going to be happening. This first operation is going to be calculated, and the result of that is going to be applied against this divided by 5. So that's why, if we do it, that's even better, maybe to make clearly understandable to us that this is what we're doing. But it doesn't, for the compiler, this is what is going to happen. And actually, even mathematically, it doesn't matter. Even if you do this, this is going to be giving you the same result mathematically speaking, because if you take, imagine the value is 1 or maybe 0, maybe it's much clearer. 0, if you divide 0 by 5, that's 0. 0 multiplied by 9, that's 0. Or if you just multiply 0 by 9, that's 0. Divided by 5, that's 0. I mean, this is the associativity of the anyways, this is not the associativity. I mean, the associativity is the rule that when we have in the precedence rule, when you have like this different operators, they have like different priorities, but on the same level of priority, you always start from the left to the right. If either it's multiplication, division, modulo division, or minus and plus, the addition and subtraction. Any other questions? Now we're done with this one. So this is already done. So let's try to continue and see what is left. We would like to have 3 mutator methods: set value, that sets the value; set scale, to set the scale either F or C; and set value and scale, to set them both. And this is going to be something similar to what we already did in the constructor when we had that set scale and set value. So if we go for set value, just we set only the value. This is going to be something like this, but without this other one. So let's just set the value over here. I'm just going to paste this and name it set value. Of course, now I need to specify something. I have a mistake here. Do you know what is my mistake? Not the signature, the return data type. I have to make it, because it is not returning anything, I have to make it void. Because remember, the constructors do not have any return data type. That's why when I copied from the constructor, I did not have any return data type. But methods should have a return data type. If it's nothing, that's void. If it's something, that's the data type that I'm returning. Now this is the set value. Set scale is going to be something like this one. And again, I'm going just to copy this constructor, and paste it here and name it set scale and void, yes. And I don't need to change the value because I'm just putting something in the scale, and I'm also checking if the scale is alright with the same type of checking. If it's not C or F, I am going to put by default a C. What is left now is the other one that takes 2. I'm going to copy something from that constructor, the set value and scale, to set both of them, and this is going to finish my mutators, the requirement for my mutators. So I'm going to, it is named set value and scale. So let's copy this from here and let's put it as void set value and scale. So this is the name of the method, and I'm going to be doing exactly the same thing that I did from that constructor actually. There are some ways to improve this. I'm not showing you the best and more compact way to deal with this. I'm just showing you how to straightforwardly answer the questions. There are some improvements that we can do, but I'm not going to go to that road. For now, maybe later on, inshallah, we might do that. But for now, I just would like you to do just the minimum to meet the requirements. Now I need to include the suitable toString method, which is something really quite easy. toString, remember what I need to do for the toString? Public, it has to be string, and toString, that's it. It has to be actually with no arguments, and then I need to return what do I want to return. For example, if you call toString, I'm going to display value plus maybe a space, and then plus the scale. So I'll display the value, space, and then the scale. So this is going to be my text that I am returning. The last one is to compare the equals. So the equals, how can I use that? Public return data type is equals. What is the return data type for equals? Boolean, because it's either true or false. So this is Boolean. Yes? So the return data type is Boolean, and then I need to name it equals. And in between parentheses, what should I put? True or false? No, because the true or false is what I'm going to return. But I'm comparing. The equals allows me to compare a temperature with another temperature. So I need to put another temperature. Let's say this is the other one. And the other temperature, how can I decide that this is that these two are equal? If they are going to be equal, if my value this, let me show, maybe use this dot value is the same than the other dot value, and this dot scale is the same as the other scale. Now if they have this, the value of this class is compared to the value of the other one, and they are the same, I need to compare the scale to see if both are the same on this class and the other class. If they're all the same values and scale, I will say, okay, these two are the same. And this is my example, my way to deal with these equals. So now this is done. The last thing that I need to be doing is just to test all this, all the methods and constructors. So how to test all of them? Well, let's go to this main and let's instantiate some temperatures. T1 equal new temperature. Look at this. When I have an overloaded constructor or overloaded method, the NetBeans is allowing me to help me choose which one do I want. Do I want like the constructor that takes no arguments? In this case it is going to be, this one is going to be executed with putting 0 in the value and C in the scale. If I'm putting, for example, 58, now I'm calling one of the constructors, which is the one that takes a value, and it is going to put the value into the class instance variable and C as a scale. So I can just have, let's say, because I have four constructors and I'd like to test them all, I'm going to name T1, T2, T3, T4, and this one I'm going to put like the temperature, only the value. This one is going to be only the scale, and in the other one let's put the value and the scale. Now if I do something like T4, this is going to display, it is going to call the toString method, and it is going to display the 34C. Let's have a look at what am I seeing. 34C. Or maybe if I do something now, let's have this, for example, this T1, so I can compare T1 with T4. If they are equal, I'm going to set the value to 34, and now I'm going to like display, is S1 T1, is it equal than T2? If I'm doing this, what would be the result? False. Very good, because these are two different objects. But if I do this dot equals, this is going to be true. Let's run this to see them. While T1, is it equal to T2? because they do not have the same values. They're not the same. But if I change it to T4, will this make a difference now? For this one? It's always false for this one, because T1 and T4 are complete different objects and in different addresses. But this one, I am comparing what's inside of T1. I just put 34, and the C it's in the by default, and here it has 34 and C. So this should give me true. So if I run this, this one is false. If I just compare with the double equal sign, but with the equals, that's true. What happens if I change the signs? Like T4 here and T1. What do you think? Is it going to make any difference? No, it's exactly the same thing. So that's it. So that's the example. We can try some other things, like for example, say T2 and set value and scale, and I can put whatever I'd like to be putting, and scale it puts up F, and then maybe we can just display T4. T4 is in Celsius, right? This T4, it's in Celsius. Let's display T4 dot get temp in Fahrenheit, so we can see it converted. And maybe, so this is T4 in Celsius, and then when we convert it, we're going to see it in Fahrenheit. So this is, I don't see F. Why? Because this is just a number. This get temp Fahrenheit just returns a double. That's why I'm seeing here just the double. If I'd like to see something else, then I just, for example, plus T dot get. Do I have the get scale? No, I don't have the get scale, so I cannot do that. I can just add it myself as F, because I know that this is Fahrenheit. So now if I'm doing this way, it is going to display like that. What happens if I just use get without this one, just get temp in Celsius? If I run this, so this is from this one, and this is from this one. Because it's the same value, it did not do anything. When it went here, it asked the question, is scale is C? Well, yes, it just returned the value 34. That's the same one. So this is how we use this method overloading, these constructors, those getters and setters, to have some class that can be useful to use, like if I'd like to use to convert things, for example, like in this case, or maybe just to be able to store some information inside of that class.